In this video, we'll see how to work with rational numbers and rational expressions. So let's review some different types of numbers first. We have whole numbers. These are positive numbers with no fraction or decimal parts. We have integers. These are numbers that can be written without fraction or decimal parts, but so they can be negatives as well. And then we have rational numbers. And these are numbers that can be written as a fraction. So if you can write a number as a fraction, it's a rational number. So sometimes it's helpful to look at a diagram to understand how these numbers work together. So if I look at whole numbers, the number 5 is a whole number, but it's also inside this integer oval because 5 is also an integer, right? It's a number that can be written without a fractional or decimal part. And 5 is also a rational number because I can express 5 as a fraction, 5 over 1. An example of a number that's an integer but not a whole number would be something like -8, let's say. Right? It's not whole because it's a negative, but it's also a rational number because I could write this as -8 over 1. And then an example of a number that's a rational number but is not an integer or a whole number would just be something like, let's say 4/5. Right? It's a fraction, so it's not a whole number or an integer. Okay. Other rational numbers could be things like 13% is rational. Decimals are rationals, even if they're repeating decimals, like 0.3 repeating, because I can convert that into a fraction. Right? Those are examples of rational numbers. So I want to classify the following as whole, integers, or rational numbers. So I look at -45. I know it's not a whole number, but I do know it's an integer. And if it's an integer, it's also a rational. You can see that here. If it's in this integer circle, it's also part of the rational oval. So if it's an integer, it's also rational. 32%. 32% is not a whole number. And remember, integers have to be without decimal or fraction parts as well. So 32% is only rational. 8 and 7/9. Again, it's got a fraction or a decimal part, so it's only rational. I can express 8 and 7/9 as a fraction. And 21. It's no fraction or decimal part, and it's positive, so it's whole. And all whole numbers are also integers, and I can express 21 as a fraction, so it is rational. We also have these rational expressions. They're expressions that have fraction bars in them. So if I am going to simplify a rational expression, I'm just going to simplify everything in the numerator and the denominator, and then I'm going to divide. It's almost like there are big parentheses around those things. So let's look at this rational expression. K squared minus the quantity k minus h, all of that over 4. Well, first thing I'm going to do is I'm going to substitute for my variable. So k squared is 4 squared minus 4 minus 5. And all of that's over 4. Well, I'm going to follow the order of operations. 4 squared is 16 minus 4 minus 5 is -1 over 4. 16 minus -1, same thing as saying 16 plus 1, so I got 17 over 4, and that's my final answer. All right, here's some problems for you to practice. I want to classify 99 as whole, integer, or rational. It has no fraction part, and it's positive, so that makes it a whole number. If it's a whole number, it's also an integer. And if every integer and whole number are also rational numbers, I could express 99 as a fraction, 99 over 1. -0.32. It's not whole because it's negative and it's got a decimal piece to it. It's not an integer because it has a decimal piece to it, but I can express it as a fraction, -32 over 100, so it's just rational. -5/11. Again, it's got fraction piece, so it's not integer or whole, but it is rational because it's a fraction. Finally, I want to simplify these expressions, so I'm going to substitute. B is 5, so I'm going to write -5 times 5 plus 6 plus 6. All of that is going to be over 5. So I have -5. 5 plus 6 is 11. 11 plus 6 is 17. And that's going to be all over 5. I can cancel out these 5s here. right? So this is just going to be negative 1 times 17 over 1. And the answer to that is just negative 17. In my next example here, I have q squared times yp plus 6, all of that over 4. Q is a negative 2, so I'm going to square negative 2. Remember, that should be in the parentheses because q squared means q times q. And 4 plus 6, all of that over 4. Negative 2 squared, negative 2 times negative 2 is positive 4 times 10 over 4. Now I could solve this. 4 times 10 is 40. 40 divided by 4 is 10. Or I could see that I can just cancel out these 4's here, and I will get my answer of 10 that way. And that's how we work with rational expressions.